The Ohm's law we have learned before can solve simple series and parallel circuit calculation problems. But in reality, we encounter mostly complex circuits. For example, circuits even have more than 2 power supplies. For example, the circuits on common printed circuit boards are crisscrossed. In this case, using only Ohm's law, it is difficult to analyze and calculate the circuit. What kind of relationship exists between current and voltage? In this lesson, we will learn the famous Kirchhoff's laws. It will be our future important tool to solve complex circuit problems. Before learning Kirchhoff's laws, let's first learn the definitions of branch node. The definitions of loops and meshes. A branch refers to a branch of a circuit with the same current passing through in the circuit. Node is the connection point of 3 or more branches. A loop is an arbitrary closed path in the circuit. A mesh is a single closed path that does not contain other branches. Based on the circuit shown in the figure above, we set the number of branches as m. Node number is n. The number of loops is L. And the number of meshes is Q. According to the definition, we can get m equals 3, n equals 2, L equals 3, and Q equals 2. Now please think about a question. Find the values of m and L and Q. Now let's officially learn Kirchhoff's current law. The statement of Kirchhoff's current law is that, at any moment, the algebraic sum of the current flowing into any node is always 0. Its mathematical expression is sum I equals O. For node A in the figure, it should be noted that when applying Kirchhoff's current law, we must first specify the reference direction of current in the circuit. When the actual current direction is the same as the reference direction, the current is positive. Otherwise, it is negative. Here we specify that the current flowing into node A is positive. According to Kirchhoff's current law, we can the expression between the branch currents. Negative I1 plus I2 minus I3 minus I4 equals 0. This equation can also be written as I1 I3 I4. In this way we can conclude that another expression of Kirchhoff's current law. The current flowing into an arbitrary node is equal to the current flowing out of the node. The mathematical expression is sum IIN equals sum IOU. Suppose the generalized node is defined as follows. So we can generalize Kirchhoff's current law too. The algebraic sum of the currents flowing into any closed surface of a circuit is always equal to O. Now let's learn Kirchhoff's voltage law. The statement of Kirchhoff's voltage law is, at any instant along any loops, reference, detour, direction, the algebraic sum of voltages of each segment of the loop is always 0. Its mathematical expression is sum U equals O, as shown in the figure, and the selected direction of travel is clockwise. According to Kirchhoff's voltage law, we get UE minus USE plus UR plus USM plus US plus US 4 equals 0. Combined with Ohm's law, the formula can be converted to negative R1 times I1 plus RR times R plus R3 times I3 plus R4 times I4 equals US1 minus US4. In this way we can obtain another expression of Kirchhoff's voltage law. That at any moment, along the reference detour direction of any loop, the total voltage drop across the resistors in the loop equals the total voltage rise of the power supply. The mathematical expression is sum IR equals sum US. Kirchhoff's laws in circuits is the basic laws of voltage and current. It is the basis for analyzing and calculating more complex circuits. Kirchhoff's laws include Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's laws describe the relationship between current and voltage in each branch. This relationship only depends on the circuit structure, but is irrelevant to the properties of the components that make up the circuit and the reference direction of the circuit. Using Kirchhoff's laws, after listing the equations of each independent loop, we can quickly calculate the current value of each branch. Please use Kirchhoff's law. Calculate the current through resistor R1 in the figure.